Right, welcome back. So we're going to start with question 2. Uh, we finished question 1 and you said you had more questions. So question 1 was basically talking about the first principle, and now we're going to apply different rules of differentiation to differentiate different expressions. Yeah. So on this one, I think the rule which we're going to work with on most of these questions is the power rule, looking at just the way the questions are. So we're going to use the power rule to solve most of these questions. Yeah, so I think we can begin. Okay, so the question says differentiate with respect to x. So we're differentiating these questions with respect to x, and we're going to be using the power rule for questions like this one, where we need to apply the quotient rule. Here we can also use the product rule. Even here I can use the quotient rule. I'm not going to use that for some reason, because I'm seeing these questions, the simplest way you can solve them is by using the power rule and just simplifying the expression so that the power rule applies. Okay, so we begin with the first one here. So this is the first one, which is a. So we have x to the power 5. Then they are asking us to differentiate this with respect to x. So the first thing we're going to do is we're going to say let y be equal to x to the power 5. So now to differentiate this with the power rule states that if you have a function which is in the format y is equal to a x to the power n, to find dy dx of this function, you simply, to find dy dx, or the derivative of this function with respect to x, you simply multiply the power by the coefficient of x. So we're going to say n times a, we're going to get a n, and then we're going to say x, and then from the power we're going to subtract 1. So we're going to have n minus 1 there. So this is the expression, this is standard for the power rule. So given this function here, y is equal to x to the power 5, the best way to solve this is by using the power rule. So how do we do that? Remember what I said? You first multiply the coefficient of x with the power. So to find dy dx of this function, we're going to multiply the the power with the coefficient of x, and in this case the coefficient of x is simply just 1. So we have 1 in front of x. So we're going to multiply 5 times 1, which will give us 5. Now I'm going to write x, then from the power I'm going to subtract 1. So I'm going to have 5 minus 1. So the final expression of this equation will simply just be 5x to the power 4. This is how you differentiate using the power rule. Then let's move on to the next one. The next one is this one. So we'll do the same. We're going to say let y be equal to x to the power negative 1 over 3. So we'll do the same. Negative 1 over 3 times the coefficient of x here is 1. We're going to get negative 1 over 3, and then we have x. Then we subtract 1 from the power. So we're going to have negative 1 over 3 minus 1. So this is going to be, so we say negative 1 over 3 minus 1. This will give us negative 4 over 3. How have I found that? So it's important to solve these questions step by step. So this is just me trying to solve this power here. So we're going to say negative 1 over 3 minus 1. We find the common denominator. So find the common denominator here. The common denominator will be 3. And then 3 into 3, that's 1. 1 times negative 1 to be negative 1. Then 1 into 3. Oh, sorry. Yeah, 3 into 3 is 1. 1 times negative 1 is negative 1. Then 1 into 3, the answer is 3. 3 times negative 1, you get negative 3. So when you add the numerators there, you get negative 4 and then over 3. So the final expression of this answer will be 1 over 3, negative 1 over 3, then x to the power negative 4 over 3. So this is the solution to this question here. Okay, so do you have any questions before I proceed to this one?
No, I'm clear.
So let's look at this one. So we're going to say let y be equal to 4 root x to the power 3. So 4 root x to the power 3. So what this means, if you have any question that is in this format, you first need to simplify the expression. So how do we simplify this? So we say let y be equal to that. How do we simplify this? So this can also be written as 4, then x to the power 3 in brackets, then the square root of anything is just the same as 1 over 2. I mean, it's just the same as that thing raised to the power 1 over 2. So we can multiply these 3 and 1 over 2 there. So we'll get something like this. 4 x to the power 3 times 1 over 2, we're getting 3 over 2. So remember what I said, to find dy dx, we simply multiply the power with the coefficient of x. So we're going to say 3 over 2 times, so we're going to say 3 over 2 times 4. Then we have x raised to the power 3 over 2, we say minus 1. So to find dy dx, this will be 3 over 2 times 4. This will give us 3 times 4, that will be 12. 12 divided by 2, the answer is 6. So get 6 there. Then we say x raised to the power 3 over 2 minus 1. You do the same, you solve the fraction. 3 over 2 minus 1. You find the common denominator. The common denominator is 2. 2 into 2, 1. 1 times 3, we get 3. 1 into 2, 2. 2 times 1, we get 2. So 3 minus 2, the answer is simply 1, then over 2. So we're getting 1 over 2 as the power. So remember what I said, any number raised to the power 1 over 2 is simply just the square root of that number. So this can also be written as 6 root x. So this is how simple this question is. Let's look at this one. So this one, we're also going to say let y be equal to 2x squared plus 7x minus 4. So how do you differentiate this one? It's also simple and straightforward. So we say dy dx is equal to, so 2 times 2, the answer will be 4. We say x, 2 minus 1, the answer will be 1. So x to the power 1 is simply just 1. And then when you differentiate this one, we know that this x is raised to the power 1. 1 times 7, the answer will be 7. Then you're going to get x, then x, you subtract the 1 from the power, so 1 minus 1 to be 0. So x to the power 0, we're going to have x to the power 0 there, because 1 minus 1 will be 0. Then this 4 is a constant. So the derivative of a constant is simply just 0. How is it 0? When we say y is equal to 4, then we find dy dx of this. We know that this 4 can also be written as x to the power 0, because x to the power 0 is 1. 1 times 4 to give us 4. And so if we say we differentiate this dy dx of this, 0 times 4, this will give us 0. So we know to say anything that we're going to get this side multiplied by 0, the answer will still be 0. So that's why we say the derivative of any constant is simply just equal to 0. Okay. So this can be simplified. Dy dx is equal to 4x, and then x to the power 0, this part will give us 1. 1 times 7, this will just give us 7. So this is exactly how you're supposed to solve this. Okay, so let's quickly move on to this one. So I'll leave some questions for you to solve as an exercise. So, okay, let's let's do this one. Okay, this one I'm going to leave it. You solve it as an exercise. Let me do this one and this one. Then this one you're going to solve it as an exercise. Okay, so let's do this one. So we have 4 over x to the power 3 and plus x to the power 3 over 4. So this can also be written as, okay, we first say let y be equal to this same expression. So this can also be written as 4. When this x goes up, we're going to have x. This positive 3 will become negative 3. And then we'll have plus x to the power 3 over 4. So differentiating this or finding the y dx of this question is simply just going to be negative 3 times 4. When we multiply the power negative 3 times this 4 here, we're going to get negative 12. Then we get x there. Then negative 3 minus 1, this will give us negative 4. Then we say plus. We have this 3 times the 1 in front of x here. We're going to get 3. Then we have x. 3 minus 1, we're getting 2. Yes, and this is being divided by 4. So this is how you differentiate this expression. But if you want, this can also be taken back down so that it looks like this one. So this can be simplified further as negative 12 over x to the power 4. So when this goes down, the negative on the power there will become a positive. So we say plus 3 over 4 x squared. So this is how you differentiate such expressions. Okay, so I'll leave this one. Let me solve this one. So this one will also say let y be equal to the root of x over x squared, then plus x squared over the root of x minus 5. So we can simplify these expressions before we start differentiating. So how do we simplify such expressions? We know that any number raised to the power, any square root of, the square root of any number is simply just that number or that variable raised to the power half. So this can also be written as y is equal to, this x can also be written as x to the power half times this x which is down, if it goes up, it's going to be x to the power negative 2. It's called if it goes up. And then when we say plus, we have x squared, and then we're multiplying this by, remember this is the root of x, which can also be written as x to the power half. But because it has gone up, it will have a minus, and you say minus 5. So when you are multiplying two numbers with the same base, you simply just add the powers. So when you add half minus 2, you are going to get x. So when you add half minus 2, you're going to get negative 3 over 2. So you can solve the fraction. Then we also have plus here. So when you add 2 and this one here, we're going to get x to the power 3 over 2. Okay. So this is what you're going to get. And then we have negative 5 this side. So now it's just a matter of differentiating now. It's differentiating this function. Simple and straightforward. So differentiating this will simply be, you first multiply the power with the coefficient of x. So negative 3 over 2 times 1, you're getting negative 3 over 2. Then we have x to the power negative 3 over 2 minus 1. We have to subtract. Okay, and then we have plus. This part will do the same. 3 over 2 times the coefficient of x. This will give us 3 over 2. Then we have x 3 over 2 minus 1. Then the derivative of a constant is 0, so we can leave it. Then we have this is dy dx, is not 1, dy dx. So dy dx is now going to be equal to, so simplifying this, we're going to get negative 3 over 2, and then x to the power. So when you subtract negative 3 over 2 and negative 1, you have something like negative 5 over 2. When you solve this fraction here, you get negative 5 over 2. And then you say plus. So when you subtract here, you're going to you're going to have when you subtract 3 over 2 minus 1, you're going to have 1 over 2. So you have 3 over 2 here, and then x to the power 1 over 2. So this is the solution. So if you want, you can simplify this further. You can simplify this further. Let me simplify it from this side. But otherwise, this is the final answer. But for the sake of any more maths, you can simplify that further. Okay, let's simplify. So we have our dy dx is equal to, so we have negative 3 over 2. So this can also be written as, let me put this in brackets, can also be written as 1 over x to the power 5 over 2. So I've taken the x down because it is negative. Then we say plus 3 over 2. Then we have this half here. Remember, anything raised to the power half is simply just the square root of that thing. So in this case, x raised to the power half, simply just the square root of x. So we can do the same even on the denominator there. So dy dx is equal to negative 3 over 2. And then this will be 1 over the square root of x, and of course raised to the power 5. Then plus 3 over 2 root x. Dy dx will now be equal to negative 3 over 2. Yeah, so if you want, you can simplify this further, which can be something like x squared root x plus 3 over 2 root x. Yeah, but if you want, you can leave it here, you can leave it there, you can leave it there. You still be given 2 marks. Okay, so do you have any questions on this question before we proceed to the next question?
No, I don't have any questions.